Alrighty, what is a derivative? A derivative is one of three of the most important things of calculus. Limits come first, these things. They create derivatives. And then after derivatives, later on comes something called integrals, which is the inverse of derivatives. So basically these are the bread and butter of what calculus is about. And so what is calculus about? Well, it's about the derivative, which finds the slope of a function at a given point. Before calculus, to find slope, you needed 2 points. With calculus, to find slope, you need 1 point, which doesn't make much sense. But with a limit, it does. Watch this. These are the different forms of saying derivative, differentiate. All right, we'll talk about those. Let me draw you a picture of what finding the slope at a given point means and how that came about. So let's say we had a curve. Okay, let's say that's my curve. All right, if I want to find the slope at this point right here, you kind of see it looks like that. I find the slope at that point. But before calculus came about, what they had to do is to find that slope, you had to get 2 points and make a secant line. Now, that isn't very accurate to what the slope is at that exact point, because the 2 points are so far away. But that's how we used to do slope. To find slope, didn't we need to do a little right triangle here? And then we have to do the change of y and the change of x. Change of y, change of x. That's what was happening. But we had 2 points. So what happens with calculus, people started noticing, what if, there's my dot again, same dot as this one. What if we brought the 2 dots closer together? Isn't my secant line getting a little bit more accurate to my slope? Yeah. Do you see how my change of x and change of y are getting smaller? Okay. And then they started going, well, what about this limit thing we're talking about? I want the slope at 1 point. Well, I could actually find the actual slope at that point. It's called a tangent line. And I could do it without 2 points. I could do it with just 1 point. Instead of having secant lines to approximate, I get all the way closer and closer and closer together to a point. I just have 1 point, and I found the slope there. And these are different ways of saying that. Now, what it's saying here, if you go back to this picture, the limit as change of x approaches 0. Do you understand slope is change of y over change of x? That's slope. All right. But what happens if we get change of x equals 0? Well, technically, if the bottom of the denominator is 0, that's impossible. But the limit says, what if we are getting closer to 0? I'm not saying we have 0, but what if we got 0? That's what a limit does. It allows you to think, what if? Well, if your bottom were to be 0, well, then we maybe could find the slope at a point, because all of a sudden my change of x is 0, thus I can find the slope, which is pretty cool. So the limit as the change of x approaches 0 of slope, that's the derivative. And then so they went to this, which is the slope formula. Okay, if this was f of x, if this was x, f of x, f of x. It's kind of complicated, but basically if you do slope with these 2 points, this function is f of x, this makes the derivative. This is the derivative. You might even do some derivatives using this method. It's not very pretty, it's a lot quicker. This is just the building block to where it comes from. But derivative is all about slope. As the bottom, change of x approaches 0. So we get past this after a while. We throw limits kind of away, and we start using the notation for derivatives. These are the most common notations for derivatives. All right. This one and this one I use the most, personally. This little notation, it's called a prime. You hear me say that a lot. Okay, it's not like a first power. It's called a prime. Anyways, those are derivatives. So you say the derivative of, if you have f of x and you put this little thing, it means the derivative of f of x. You also have dy dx, the change of y over the change of x. You have d over dx of f of x. Okay, this is saying that d over dx is the derivative of f of x. So you'll see a lot of these different notations, possibly, when you hear the word derivative. And all derivative is saying is the slope of a function at a given point, 1 point. You don't have to do the secant line anymore. All right, and that slope at 1 point is huge. You might not think like, who cares? I don't care, whatever. It is really big, and it's the whole premises of what we get into in this whole entire subject of calculus. Okay, now, where are the functions not differentiable? Where do we not have a derivative? Where do we not have a slope at a given point? Well, there are three situations where we do not have a slope at a given point. The first one would be anytime you have a jagged edge. Let's think about that. What is the slope at this point? Well, my slope from this side is up. My slope from this side is, just down. I have two slopes at that point. Yeah, which one? I don't know. Do you see I have two slopes? You don't know what's your slope. So at any jagged edge, we do not have a derivative. We do not have any slope. So that's one situation where we run into issues. We do not have a derivative in this situation, which we saw with limits. Okay, because the slope, well, coming from both sides, I have different slopes. This is my slope right there, and my slope for this one this way. At this value where it breaks, I don't have a slope. So it breaks like this, it's not differentiable because there's not one slope. Alright, and the last one, hopefully you can predict, maybe, can you? Is an asymptote. If you have an asymptote, okay, when you have an asymptote, you do not have a slope at this vertical asymptote. Even though they look like, oh, they're both going up to infinity, so the infinite slope. No, you do not have a derivative at an asymptote because you don't have a given slope from both sides. Now, here's one thing too about a derivative. Okay, if it is differentiable, I mean if it has a slope, like it has to be continuous. Okay, so if it is differentiable, if you can take the derivative of something, then it is continuous. Okay, if it's continuous, does that mean it's differentiable? No, because this continuous? Well, yes it is. Is it differentiable? I know. Do you see how this isn't continuous? So you can't derive it. This isn't continuous, so you can't derive it. Okay. So if it's discontinuous, it's not going to be differentiable. Alright. So good luck with derivatives. It's important to understand slope at one point. Recognize these formulas. Okay, you're going to get very used to them. There's going to be good shortcuts. You're going to maybe see this shortly, but then you kind of will put that to the side using limit notation to find your derivatives. And remember, jagged edges can't have a slope. Breaks can't have a slope, and asymptotes can't have a slope.